Example 21, okay, given that cos x equal to -4/5, so, and it is in the third quadrant, so here is the third quadrant. So cos char adjacent over hypotenuse, and then you will get your -3 here. Alright, so from, okay, back to your original question, asking about sin x over 2. So from the half angle identity, we know that 2 sin square x over 2 equal to 1 minus cos x. Alright, so we want sin square x over 2 equal to 1 minus cos x over 2. So you want to eliminate your square root here, okay? You want to eliminate a square, so we need to square root this one, 1 minus cos x over 2. Right, so x is 180 less than x less than 270 in the third quadrant. So our angle here is half, so x over 2, half from here is 90 and 135. So means that our half x over 2 is in second quadrant. So when in second quadrant for sine, okay, you know this one. So sine for second quadrant, it is positive. So means that sine x over 2 equal to 1 minus cos x over 2, okay, square root. So we know that your cos x is -4/5, okay. So -4/5 over 2 here, okay, you will get 9/10, which is also 3/10. Okay, example 22, we are not in the inverse trigonometric, so we need to verify this left hand side is equal to right hand side. So from here, first thing first, you know that you need to let tan inverse 1/4 equal to A, so we have tan A equal to 1/4. Same goes to here, tan inverse 3/5 equal to B, so we have tan B equal to 3/5. So what you need to do is that you need to draw the angle, okay, here because of positive here. Right, so tan toward opposite over adjacent, so you'll get here is 17, right? So this is your A, and then same goes to your B, right? So this is your B toward opposite over adjacent, right? So you'll get your hypotenuse is 34. So from the given question, from the left hand side, okay, left hand side we have tan inverse 1/4 plus tan inverse 3/5. Right, so what you need to do is that, okay, you can use any compound angle formula. For example, you can use sine, cos, or tan. So for example, here I use sine here, right? So for sine here, it will be sine in the bracket. So our tan inverse 1/4 is now A. Alright, same goes to this one is equal to B. So plus B. So we have learned before our compound angle here, right, which means that it is equal to sine A cos B plus cos A sine B. Alright, so sine A you can find from here, right? So what you get here is 1/17. Cos B, find from here, you will get 5/34. Right, cos A, you will get 4/17. Sine B, you will get 3/34. Okay, when you calculate this one, okay, you will get 17/2, right, which is equal to 1/2. Okay, but then in the original question, the question asks you to prove tan inverse 1/4 plus this one equal to this one. There's no sign here for sine. So what you need to do is that you bring sine to the other side, become sine inverse. So when you bring sine to the other side, left over only tan inverse 1/4 plus tan inverse 3/5 equal to sine inverse 1/2. So when you press your calculator here, you will get pi/4. So you have proved that tan inverse 1/4 plus tan inverse 3/4 is equal to pi/4. Okay, example 23, okay, similar to example 22. Alright, so from here, first thing first, we let tan inverse 1/3 equal to A. So what you get here is tan A equal to 1/3. So just draw your angle here. Alright, so this is your angle A toward opposite over adjacent. So you will get here is sec tan. Alright, so the question asks you to prove left hand side equal to right hand side. So like before, we can choose any sine, cos or tan, but then in this original question is already given sine inverse. So what you need to do is that you need to make it sine to tan inverse 1/3, which is equal to sine in the bracket 2. Here tan inverse 1/3 is already become OA. So this is double angle formula. So you need to write it as 2 sine A cos A. Okay, by referring to this angle, right? So you will get 2 in the bracket 1/sec tan, right? And 3/sec tan, okay, which is equal to 3/5. Okay, but then the question asks you to prove that 2 tan inverse 1/3, there's no more sine. So sine you bring to the side, you will get 2 tan inverse 1/3 equal to sine inverse 3/5. So you have proved this one.